Okay, so I'm very happy to be there. So, well, this is very impressive. So I'm going to present you some ongoing work with Raya and Roman. So is that the way it works? Okay. Yes. Okay, so we're going to discuss some potential climate change impacts on fertility in low and middle income countries. So there is some evidence to think that there might be some positive effects of climate change on fertility. So after some disaster, there are some evidence of increasing fertility. Plus, we had this presentation yesterday by Francesca showing that deviation from standard SPEI has an effect on early marriage in Bangladesh. But at the same time, there are reasons to consider that there is negative effects of climate change on fertility through effects on earth, or the fact that sometimes exposure, I'm sorry for the mic, the exposure to adverse environmental conditions tend to decrease the ideal family size according to women in some sub-Saharan countries. Sorry. Moreover, we could expect some direct as well as indirect effects of climate change on fertility, and they are quite complicated to disentangle, and there is more and more evidence on this subject. However, with some notable exceptions, most studies that have been conducted yet, and when I say some notable exceptions, I'm in particular thinking about this recent paper by Tidio et al., but most of the time it's focusing on a single country or a single event. And so with Roman and Raya, what we want to do is to try to provide a complementary view with the use of cross-country evidence with a database of aggregate index of fertility. However, we can have this question. Is there already a global fertility database that would let us tackle this challenge? And there is a global fertility database that was provided by the United Nations this summer, but it's not fit for our purpose due to the way it was built with Bayesian estimation. So what we do is construct an harmonized data set that is harmonized across countries over a long time period using multiple demographic and health surveys. So you all know DHS data, but I'm going to say again some little things, and in particular the fact that in the record of women there is a birth history. So this birth history is usually used to estimate fertility rate over the 36 months that precedes the end of the survey. However, it's theoretically possible to estimate fertility using this birth history over a different time period with a different time span in a given spatial unit considering a restricted sample. So what we want to do is construct a database at a national as well as a subnational level that considers different fertility index with different frequencies, i.e. year frequency, quarterly frequency, and monthly frequency. So for the spatial units, we rely on the recent LiveWell database. So that comes from a paper that was published in Scientific Data a week ago, and that is co-authored by Roman, that is here, and by Camille Belma. And so this database provides an harmonization of the different regions that are considered in the DHS studies. So this is possible then to link several DHS surveys at a subnational level. And then what we do is estimate the total fertility rate, the age-specific fertility rate, and the total fertility rate broken down by educational attainment group with the DHS rate package that was created 3 years ago. So then, if you consider several DHS studies and you go back in time with the birth history, then you have an overlap of your estimates. And there is this question, is it possible to consider different estimates of fertility to get one estimate that would be a bit more robust? So what we do is try to combine this information with what is known as inverse variance weighting. So the idea is the following. We derive the standard error of the estimates with a jackknife estimator, and then we weight it by the inverse of the variance. If an estimate is very uncertain and imprecise, then the variance is high and the weight is little. If you have a very precise estimate, the variance is low and then the weight is high. And so we're able to construct time series of fertility estimates with this method. So we're going to look at some example. First, an overview of the results. So these are the studies that are considered. So we asked to have access to all DHS studies. You can see that we don't have all DHS studies in our database because some of them are quite reluctant to computer processing. But that's work in progress, and in the end, we'll hope to have the most of it. So we consider total fertility rate at a national and a subnational level, age-specific fertility rate at a national and subnational level, and education-specific total fertility rate at a national level, and all of this at a yearly, quarterly, and monthly frequency. So when writing the slide, I thought that perhaps that would be interesting to consider age-specific fertility rate broken down by education attainment at the national level. That's due to the tote bag of the conference. So here you can look at what brings subnational heterogeneity. So yes, oh, it works. So here, this is age-specific fertility rate for Senegal from the 80s, and here you can clearly distinguish the district of Dakar from other places, which shows that with this database it's possible to take into account like this urban-rural divide in a very fine way. Then it's possible to compare our estimates with the world population prospect. So here you have an example of several estimations for Colombia. So each graph presents our estimates for 1890, 1895, 85, 90, blah, blah, blah. And so you can see that our estimates are very close to what they obtain, so to us that's a good validation of what we have. But on the other hand, they don't have exactly the same thing that we could say is due to their measurement correction of their Bayesian smoothing, whereas we have a different measure with confidence bands. And then I'm going to show you what the frequency is capable to bring with data from Bangladesh. So here we have total fertility rate that is measured at a yearly frequency, so it's quite smooth, that's okay. And then with quarterly frequency, we have this huge seasonal pattern that is super interesting, because here you can see that the variation is very important, here it's less important, and that is confirmed with the monthly frequency, where we can even get like the fine granularity of this seasonal pattern. And you can see in the end that all match very well and that there is no, mistake in the calculation. So then, next step is which other data do we want to consider? So of course we need to consider this with the relevant climate measures. And what we would like to do is possibly also consider defining growing and harvesting season for a given crop at a given location using this data set on crop calendar. And finally, perhaps that would be interesting to use data on contraceptive use, like there was a recent output from the United Nations that might be quite relevant. So, of course, there are some limitations. So there is an implicit hypothesis of no migration or compensating migration effect on total fertility rates. So perhaps a way to tackle this would be to make a re-estimation of the results restricted on the sample of women that never migrated. However, this sample of women that never migrated is also self-selected, so that wouldn't be like a bulletproof way to tackle the thing. And then there is another issue. So with the time lag, some age groups disappear from the data because DHS data focus on women between age 15 and 49, and that bias the estimates of the TFR. However, if the estimate of the TFR is biased with this problem, then the uncertainty is bigger. So with the inverse variance weighting, then we should perhaps not have this problem. However, best way would perhaps just be to focus on the age-specific fertility rate, which is also bringing more granularity to our analysis. So, to conclude this presentation, so we produce a database of different fertility indicators at a national and subnational level in an harmonized way in low and middle income countries with various time frequencies, and to me that is of interest just by itself. And then the time frequency, as well as the wide scope of this database and its spatial granularity, seems suitable to bring a complementary view and approach to the study of the impact of climate change on fertility. Thank you.